Hope everyone's doing okay. Today we're taking a look at solving systems using the elimination method. So the warm-up activity is asking us to add 123.456 to 678.91 by hand. This will be important because it's all about place holding and adding straight down. So if we take 123.456 and we want to add 678.91, we need to make sure we line up in the correct spots. So 600 is in the hundreds, 78.91, and then at the end of that 1, we can add a 0 for that last placeholder. You always add from right to left, so that's what we're going to do. 6 plus 0 gives us 6. 5 plus 1 also gives us 6. 4 plus 9 gives us 13. We put the teen or the 1 up there, and you drop the 3 down. The decimal would stay dropped. From here, we now have 1 plus 3, which gives us 4, plus 8, which gives us 12. So the 1 moves up, the 2 comes down. 2 plus 7 is 9, plus this 1 up top gives us 10. So the 1 goes up, the 0 comes down. And then 1 plus 1 is 2, plus 6 gives us 8. So if we add those two together by hand, you should get 802.366. All right. This is important because we're going to add straight down like this today, and that is where solving using elimination is going to come into play. Before we talk about that, though, let's take a look at this question that we actually did in the notes the other day. It was example A from the day 2 substitution notes. As you can see, the problem with this question when we were doing it was that they were both in standard form. So here we have an equation in standard form, and then right below it we also have an equation in standard form. So what we had to do in order to do substitution was we had to rewrite one of the equations. So notice in this specific example, this person subtracted the 2x to the other side. When they did that, they got y equals negative 2x plus 5. They then took this negative 2x plus 5 and they plugged it in for the y in this equation. Notice how they built this equation right here. And then what you had to do from there was you solved for x and y. So kind of a lot of work to do substitution in that particular example. But what if we could work with this system without ever having to rewrite it? All right. In order to do this, this is called solving systems of equation in standard form, could be more efficient using the elimination method. Elimination. All right. So this method has you add equations together to cancel a variable that has the opposite sign. All right. So let's take a look at what we're looking for with elimination. So example number 1 we have right here. As you can see, we have two equations in standard form. There's two different numbers on the x's, so we're not going to concern ourselves with that today. But if you look at y, at the y's, there's one y that's positive, there's one y that's negative, hence opposite signs. So what are we going to do? We're going to add these equations down. Physically, literally just adding them down. So 2 plus 3 gives us 5x. Positive y plus negative y gives us 0, so we can just say plus 0. And then that's equal to, because you dropped the equal sign, just like we dropped the decimal sign earlier today, 5 plus 0 gives you 5. All right? So, literally this question from above, right? But instead of solving for y, plugging in, and then doing a bunch of math here to get x, look at this. We added them together, and now we're one step away from solving for x. So we divide both sides by 5, and you get x is equal to 1. Okay? To finish this question, you need to plug x back in. So this is where a little bit more work can come into play. So you can plug x into the 2x here, or you can plug x into this x next to the 3. It doesn't matter. Either one is great, and they're both going to get you to the same spot. So let's say we plugged x into, I like the top equation, so we'll go there. We'll say 2 times 1 plus y is equal to 5. That gives us 2 plus y is equal to 5. If we subtract 2 from both sides, you get y is equal to 3. And then there's our solution, right? The solution to this question would be 1, 3. So if we're thinking mathematically, how many steps did we take to do this question? We took one step here, we added. Our second step here, we divided by 5. Our third step is plugging in our x value. And then our fourth step is literally just subtracting the number we got to the other side to get y. So that question took us 4 steps. Let's see how many it took us the other day. Well, the first step was solve for y, so here's 1 step. Plug y in, that's 2 steps. Distribute that negative, that's our 3rd step. We now have to simplify the 5x, so that's the 4th step. Our 5th step is then adding the 5 over. And then finally, our 6th step is dividing. So we're already at 6 steps, and we only found x equals, versus it took us 2 steps to get x equals with elimination. So that's just an example of why elimination is sometimes a lot faster than substitution. So let's take a look at another example. Example number 2. We don't care about the y's in this case because they're 2 different numbers, all right, with the same exact sign. But if you look at the x's, we have 2 of the same number, just the signs are different. So we add those together, right? And we're going to get the 3x with the plus negative 3x to become 0. 2 plus 4 gives us positive 6y. And then 114 plus 66, that's going to be a number. So that's 120 when you add these 2 together. So that's 0 and 1. So that's 1, 1, and 6, which makes 8. So that's 180. All right. And now we have a y by itself, so we can divide 6 from both sides to get y is equal to 30. Why do we get 30? Because 18 divided by 6 is 3, and then you add the 0 to it. That gives us 30. Okay. From here, remember, you're going to take y and you're just going to plug it back in. Doesn't matter which equation. I kind of like the first one. We're multiplying 30 by a little bit smaller number, so it might be a little bit easier. So that is going to pull us out with 3x plus 2 times 30 equals 114. So we have 3x plus 60 is equal to 114. You subtract 60 from both sides here. That is going to give us, what is that going to give us? 60, nope, 54. Yeah, so 3x is equal to 54. Divide both sides by 3, and let's think about this. 54 divided by 3, I believe, gives us 18. Yes, yeah, 18. So what's our solution for this one? Our solution is 18, 30. Okay, if I'm ever doing math too fast for you guys, by all means, pause the video at times to catch up and write things down. But yeah. That was example number 2. Example number 3. So if we're taking a look at this one, at the beginning we talked about how this was hard because it had to be in standard form. Well, in order for us to ever do an elimination question, it has to be in standard form. And this equation right here, the second one, is not in standard form. So we have to get it into standard form. If you don't remember what standard form is, it's having x and y on the same side. All right, usually x comes before y, but really we just want to match it up. So we have a 2y and a plus x, so we're going to put x to the right of y when we move it over. In this case, we're subtracting 5x to the other side, and that's going to give us negative 2y minus 5x is equal to 3. I'm now going to drop this second equation down, which is 2y plus x equals 17. Did not change it at all. And then our elimination should work just fine now. As you can see, if we add the negative 2 and the positive 2, that's going to create a 0. So there's our 0. Negative 5x plus x is negative 4x. And 3 plus 17 is 20. So we divide both sides by negative 4 here. And you get x is equal to negative 5. As always, you go back, you plug negative 5 back into the equation. It's not going to matter which one. I'm kind of feeling the first one here, so let's go first equation again. That gives us 2y plus negative 5 is equal to 17. So we're going to add that 5 to the other side. That gives us 2y is equal to 17 plus 5 is going to be 22. Divide both sides by 2, and you get y is equal to 11. All right. So then our solution for example number 3 is going to be negative 5 comma 11. And that is our introduction to elimination. All right. Try out the homework. If you have any questions, please let me know. Just message me on Canvas. Have a great day.